Hello everyone. Welcome back to Pamten's YouTube channel. And in today's session, we'll be looking at a very popular interview problem which goes by the name of Koko Eating Bananas. So the platform that I've opened up over here is LeetCode, which is what most people use for their interview coding prep. And let's start off by looking at the problem. So Coco is a monkey who loves to eat bananas. And there are n piles of bananas. The ith pile has piles ith bananas. So this is basically an array, and each pile over here has some bananas. So this is the first pile which has 3 bananas. Second pile, 6 bananas. Third pile, 7 bananas. Your fourth pile, 11 bananas. And in total, you basically have 1, 2, 3, and 4 piles over here. Now, the question basically states that the guards have gone and will come back in H hours. Coco can decide her bananas per eating speed of K. So, Coco can eat either 1 banana per hour, 2 banana per hours, or let's look at the maximum value here, which is 11. So, starting from 1 till 11, Coco can eat any number of bananas it wants to. And then the question states each hour she chooses some pile of bananas and eats k bananas from that pile, which will be the number of bananas Coco eats. If the pile has less than k bananas, she eats all of them. So here, let's say if the bananas per hour eating speed of Coco is 10, then what we'll do is Coco will eat all of the 3 bananas which are there in the first pile and then wait till that 1 hour is over, right? Then, if the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Right. Coco likes to eat slowly but wants to finish eating all the bananas before the guards return. Return the minimum integer k such that she can eat all the bananas within h hours. Okay, now let's understand this problem properly. You are given this array which is basically piles of bananas. First pile 3 bananas, second pile 6 bananas, and so on, which we've understood. And again, if the bananas per hour eating speed is more, then it'll eat all the bananas and then wait till that 1 hour is over. And if the bananas per eating speed is low, so let's say if the monkey can eat 1 banana per hour, then obviously it'll finish only one. Now let's look at this properly. So here, h is the number of hours the guard will be away. And the monkey should be able to eat all of the bananas in that time frame. So here for this particular question, this is the array and we are supposed to find out the number of bananas Coco can eat such that the minimum number of bananas Coco can eat such that it is able to finish up all of the bananas before the guard returns, which is 8 hours. So here, let's see what is happening. So let's say if the number of bananas Coco can eat is 1 per hour, then here what will happen is the total number of hours. Since here 1 banana per hour, it'll take 3 plus 6 plus 7 plus 11, which is obviously greater than 8. Now let's take the number of bananas per hour eating speed to be 2. So here per hour, it'll be 2. And then you have 1 banana. So it'll basically finish that up in the next hour. So here, what you're basically doing is 3 by 2 and then taking the ceiling of it, right? So let me explain this again. So in the first hour, Coco will eat 2 bananas. In the next hour, though it can eat 2 bananas, but there is only 1 banana left, so it will eat that. So here, the total number of hours taken will be 2. So here, this will be 2 plus 6 by 2 is obviously 3. Then you have 7 by 2. So 7 by 2. So it will be 2 plus 2 plus 2 plus 1. So that becomes 7. And then you have 11. So that's 5 plus 1, which is 2. Okay, so this is 2 hours. This is 3 hours. This is 3 twos are 6. So this is actually 4 hours over here. And this will be 6 over here. This again is greater than 8. Then if the bananas per hour eating speed is 3, let's see how this will go. So first pile, it'll take 1 hour. Second pile, it'll take 2 hours. Third pile, it'll take 3 hours. Fourth pile, 3, 6, 9, and then 4 hours. So here again, 4, 5, 6, 7, 8, 9, 10, which is greater than 8. So find the minimum number, so minimum integer k such that she can eat all the bananas. So till now, three number of bananas, 1, 2, and 3, she'll not be able to finish it within the time frame. Now let's increase it to 4. So 4 bananas, so here it'll be 1. For the next one, it'll be 2. For the next one, it'll be 2 again. For the next one, it'll be 3. So this will become 3 plus 2 plus 2 plus 1, 3, 4, 5, 6, 7, 8, which is exactly the number of hours the guard will be away. So this will be the answer for this question. Now, how can we solve this? So here, the number of hours, or let's actually look at the number of bananas Koko can eat. So the number of bananas Koko can eat, the minimum value will be 1, and the maximum it can eat will be 11 here. Because if you take more bananas than that, then obviously it will not make much a difference, because if you take 11, then it will be 1 plus 1 plus 1 plus 1. If you take any number higher than that, it will always be 1 plus 1 plus 1 plus 1. So I will set to be whatever is the max value in this array. So high will be equal to max of pints. Now, what we have to do is we have to find a number which would give us the minimum integer such that it can eat all of the bananas within the time frame. Now, what we're essentially doing is, so basically the number of bananas eating speed will be somewhere between low and high. So between 1 and 11 over here. And since this eating speed is continuous, so this will be 1, 2, 3, 4, 5 going up to 11. This is basically a continuous array. You can use binary search over here, and using binary search will solve this question. So while low is less than or equal to high. Now, going ahead, with the help of binary search, I will find the middle value. So mid equals to low plus of high minus of low by 2. Now here, this will be the number of bananas Koko can eat for now. And then I will go ahead and create another method which will give me the hours taken if it eats particular number of bananas. So I'll call this as def total hours self. This will obviously take the array which was given to us, and then this will basically take the number of bananas Koko can eat, which will be the middle value which we are calculating over here. And now in this, I'll have a variable called as hours. Let me initially set it to be 0. And for each pile in this array, so for I in piles, for each pile, I will calculate the number of hours taken. So this will basically be hours equals hours plus ceiling of I divided by number of bananas Koko can eat. So here again, if Koko can eat 2 bananas, 3 by 2 ceiling of it. So ceiling of 1.5 will be 2. So hours will be 2 over here. So again, in the next iteration, so here we have 2 plus 6 by 2, which will be 3. So 2 plus 3 will become 5. And again, here it will be 7 by 2 ceiling of it, and then 11 by 2 ceiling of it. And that is how you are calculating the total number of hours. So now that we know the total number of hours, we can go ahead and return it. So this is how we are returning the total number of hours taken by the monkey. Now, once we know it, so this is what we have to pass into this function. So here, I'll call this self dot total hours. Inside this, I need to pass in piles. And then mid is the number of bananas which the monkey can eat. So initially, this will be 0 plus 12 by 2, which is 6. So currently, we are passing in 6. So for 6, obviously, this will be able to come back before 8. Now, what happens is I'll basically store this in a variable called as result. There'll be two conditions. If the banana is able to eat everything. So here this is the number of hours taken. So if the number of hours taken is greater than h, so if it takes more time to eat and the guard actually comes back, then this would mean that the monkey needs to eat more number of bananas. So if the monkey needs to eat more number of bananas, so here low will be incremented to mid plus 1. So this is, if you remember binary search, this is how binary search works. So what we are doing is we are cutting down the entire left side space. So the number of bananas, it could be 1, 2, 3, 4 going on till 12. We got 6 and we understood that if the monkey eats 6 bananas per hour, it can actually it can actually come back. But so here this condition, if the number of hours taken by the monkey is greater than the number of hours the guard is away, this would mean that the monkey needs to eat more number of bananas. So in this case, we can cut out the entire left space. But on the other hand, if so this other condition will be basically if result is less than h, which would mean that the number of hours taken is less than the number of hours the guard is away. So in this case, obviously the monkey is able to eat all of the bananas. So if the monkey is able to eat all of the bananas, we need to find the minimum such value. So I'll say high is equal to mid minus 1. So what we are doing over here is we are cutting out the right side of the search space. So this is how binary search works. So if you know, if something exists on the right side, you cut out your entire left search space. Similarly, if you know something exists on the right side, you cut out your entire left space. Now we'll take another variable called as answer. Initially, we'll set it to be 0. And here, whenever the result is less than h, I'll store mid value in answer. So mid contains the banana per hour eating speed, and every time we have a value which is true, we'll store that in answer, and this is what we shall be returning. So I'll say return of ANS. Let's run this. And you see, all of the test cases have successfully passed. Let me also submit this. And you see that even this is successful. So this is a very famous interview question, and this is how we've solved it using binary search. Thank you very much for watching it, and do like the video, do subscribe to our channel, and I'll meet you in the next one.